People have to release cars, vehicles much faster to the market. In traditional automotives, the big ones of the world, the names that we all know about, it's typically been in silos. So it's very necessary for the design department or the engineering department to know what's happening downstream, the way the world is going to move forward, which is a lot of automation, whether it be in engineering with simulation and virtual prototyping, etc. A lot of automation on the factory and a lot of service efficiency automation. AI has been there for a long time, right? AI, analytics, etc. But it's not been realized to its fullest potential. Traditionally, what we call product lifecycle management solutions, chief information officers, I think that in all the conversations we are seeing an increasing trend of them appreciating that they don't want to manage servers, they don't want to manage storage, they don't want to manage network. Our ALM, it's called Codebeamer, it's actually doing pretty well in the market as it moves through its life cycle. That's where the concept of digital twin comes in. That's where the concept of PLM, of course, comes in.
Data is transforming the way the automotive industry functions, and today, as it witnesses rapid shifts with electrification and software-defined vehicles, it is all the more important to have a digital thread. To talk to us more in detail on this, I am joined by a very special guest, Mr. Rajkiran C., who is the Senior Regional Director and Head of Enterprise Business at the PTC. Rajkiran, always a pleasure to have you, and thank you for joining us.
Thank you very much, Mayank. It's a pleasure for me to be here.
So, starting first, with broad thoughts, as an enterprise, how important today is to have a digital, backbone, a digital thread, with the transformation that you're seeing in the automotive space. So if we can begin on that note.
Yeah, I think for the automotive industry, as it is for many other industries, complexity is increasing. People have to release cars, vehicles much faster to the market. I think with the influence of China's speed in electronics first and now in automotive, there's an ever-increasing need for speed within different departments. And those departments are the design and engineering department, the manufacturing department, service department. Now, and in traditional automotives, the big ones of the world, the names that we all know about, it's typically been in silos that their functioning has been.
True.
The engineering department does their work, throws it over the fence to the manufacturing department, and then the service department takes it over. And then there's not much collaboration we find between the different departments. So the concept of a digital thread, if you look at the actual meaning of the word thread, is actually to connect. And what does connection do? It brings more visibility. And with visibility, there are a lot of inefficiencies will be exposed.
True.
And there'll be a lot of efficiency improvement as a result of that. And then, people become more efficient and they can become faster. So it solves that fundamental problem of being slow due to everyone not knowing what to do within the organization, right? So that's what a digital thread concept is about. Now, engineering decides, or at the design phase of a product, you actually determine how the product is going to be throughout its life cycle.
Yes.
Right? So design is extremely important. So it's very necessary for the design department or the engineering department to know what's happening downstream, what's happening with manufacturing, what's happening with service, etc. And to get constant feedback from manufacturing, from service, right? From out in the field. When a car is performing, you probably need feedback about the different components within a car.
True.
You need engineering to know. It's not as though the responsibility of the engineering department is over after they design a car, because there needs to be constant iteration. There needs to be improvement in the design in the next version of that car, or release new cars into the market. Now I'm saying cars, but the same is applicable for two-wheelers, three-wheelers, commercial vehicles, everything. Right? So take, for example, the engineering department being told that a component within a car or a vehicle is failing very often. So probably someone needs to take a look at that particular component, let's say a carburetor inside an engine, and improve its version, improve its design in the next version. Right? So that's an example of a digital thread between the service department or the aftermarket department and the engineering department. A similar example can be looked at for manufacturing to engineering, where the manufacturing department says, you have designed a product and told us recommendations of the materials to be used, but this is not entirely, let's say, sustainable, or there are alternate versions that you can make, or alternate materials you can use for the same component within the same boundary constraints that you have defined and recommended. So then manufacturing should be talking at a constant basis to engineering. So that's another example of digital thread. So you see how with data as a backbone, you can have perfect visibility into the operations within an organization. So that's why digital thread is damn important. I think all digital officers, CIOs, CXOs that we have constant conversations with tell us this is important. But because of constraints of size and the ways that they've been following for years together, they've not been able to implement it in its truest form. But the attempt is there. So I think that's how relevant it is.
So what you're saying is basically it enables a lot of concurrent engineering, if I can call it to that, and also a lot of feedback, from different divisions to engineering, from market to the OEM or to the tier one ancillary,
That's
like
correct.
that.
Yeah.
And also, like you mentioned, data is the fundamental backbone that we're talking about here. The other, and I want to address the elephant in the room here, AI, artificial intelligence. What role of AI do you see, being, going forward in this entire digital thread that we're talking about?
Plenty. I mean, that is going to be the way the world is going to move forward, which is a lot of automation, whether it be in engineering with simulation and virtual prototyping, etc. A lot of automation on the factory, and a lot of service efficiency automation. And what does all of automation require? It's really artificial intelligence based on data. And to the point of breaking down silos and having a common data reservoir or a single source of truth that everyone sees, you can enable that and accelerate the AI revolution. Now, specifically speaking about AI in different areas, AI has been there for a long time, right? AI, analytics, etc. But it's not been realized to its fullest potential yet. Engineering, generative design, for example, right? You start designing a particular component or a car, and you want to now improve and get alternate suggestions on how the same component can be designed, right? Within the same boundary constraints which have been given or that the design department has given to engineering. AI can recommend that to you. Generative design is true, it is available, and it is now. There's plenty that engineers are already getting with the intelligence from generative design. And while they design, they need to simulate to know whether this is actually working. This is with real world physical conditions that they need to do that simulation. That is also provided by the system itself to do that. Now, in the traditional world, it used to be you need to release a prototype to the market, which is a few vehicles up front just to test it out in real conditions. A lot of that, and that involves a lot of costs, right? I mean, you have to create some and then you iterate the version, you improve it, and then manufacture it again. You can do virtual prototyping now, which is bringing in simulation and understanding, and in real world conditions, you can actually test it without the vehicle being manufactured, even those prototypes being done. So that's concept of virtual prototyping. That's about the engineering department. There's a lot of improvements there. All our big automotive manufacturers are using AI in engineering. They are thinking of planning of, it's on their roadmap. AI in manufacturing is probably about the example I gave you earlier about getting recommendations whether it is manufacturable perfectly, and if not, what are the alternative components to be used or the materials to be used. And also about, I talked about sustainability. How do you optimize the use of electricity? How do you optimize the use of water, gas, etc. within the factory Now, AI can give you proper recommendations if it monitors all of these to give you insights on where these areas of optimization can happen. Right. So manufacturers or the head of the plant will get proper insights from the system that says, you need to improve on these areas, and there is potential, and it pinpoints how much excess water is being used in particular processes, how that can be improved. Service side, I think one of the top things that comes to mind is about spare parts. Let's say, aftermarket department needs to stock spares and ensure there is minimum downtime for a vehicle. Right. And how many times have you left your car at the workshop with them saying this spare is not available, it'll come 5 days later. So your satisfaction has gone down because the service center has told you to wait for something that could have been avoided. So with analytics, you will be able to predict demand of particular spares within the vehicle, and actually do an optimization of how much spare inventory needs to be stocked in what region. Okay, if depending on terrain, depending on a variety of factors. So all of those correlation regression is all that needs to be done to arrive at the optimal model in which the spares or can be stocked near a service dealership or a warehouse. It needs to be stocked perfectly. So this is how across the value chain AI can be used.
Right. And how do you bring in the enterprise solutions, from a technology company like PTC? Tools like PLM, ALM, how do they come into the picture, and how can you also bring them into the context of this SDV development that we are now seeing, wherein the vehicle is going to be a lot more software defined, a lot more dependent on software. And that is also going to change the business models for the OEMs going forward. So from your perspective, what tools do you see playing a key role going forward?
Yeah, a lot of digital tools, and it's an ever evolving space. But the two that you talked about, PLM, ALM, etc., and plenty more, right? IoT, got digital twins for simulation. Let's say model-based systems engineering. All of these are, unless it's explained, it's all just buzzwords, right? But to the point I was making earlier, to break down silos and to have a single source of truth, I think traditionally what we call product lifecycle management solutions, which is essentially the electromechanical component's life being tracked from the time it's conceptualized, from the time where the requirements are defined for the vehicle, to when it's designed, developed, how it needs to be validated, and how it needs to be manufactured. For this entire process to be taken care of, we've got a central system for that, which is quite well used within the industry. Okay, so PLM, especially in fast dynamic sectors like automotive, it is used quite prevalently, which is essentially to bring a common way of collaborating between the different departments, managing change, managing versions within teams that are doing the engineering. Now, both from a hardware and software point of view. By the way, the equivalent of PLM for hardware is ALM for software. That's the application lifecycle management, where you need to accurately capture the features or the requirements that people are proposing within a new vehicle, and track it through its lifecycle, through its coding lifecycle, to when it's tested and validated, to generate test cases and validate it against the requirements which were arrived at in the beginning. That needs to be tracked perfectly, because you don't want to miss out on certain things. And you also want to ensure end-to-end traceability across what's called the V model in software development lifecycle. For these, there are very compelling tools that the market needs and is adopting. And I think for PTC, we're providing those to the market pretty well, and it's adopted by a lot of big automotive OEMs, as it is with automotive tier 1 companies, etc.
Right. Another element, Rajkiran, is also, cloud. Now, to really facilitate all of this collaboration, I think cloud also has a very big role to play here. So, if you can elaborate a bit more on that, what's really, the critical function cloud is going to play going forward, and for these OEMs, tier 1s, and other players within the automotive space, is it really a critical job right now, or a critical idea to really adopt and move to the cloud?
Yes, it is. And it's on the minds of a lot of chief information officers. I think that in all the conversations, we are seeing an increasing trend of them appreciating that they don't want to manage servers, they don't want to manage storage, they don't want to manage network. It should all be abstracted to them. They just want to manage the internal business, so to speak, right? They want to do what their companies do best and leave the administration and the patching and all of those things to the vendors, to the partners that are partnering with them on the IT side. So cloud definitely is, from an infrastructure as a service standpoint, very relevant in that space, where CIOs are appreciating that they just want to manage SLAs with the cloud vendors. They don't want to necessarily work on doing that and hire large teams and so on. That's about the hardware. But even on the software side of things, there are IT softwares like the ERP and CRM, etc. But there's also the business softwares that engineering teams use, like PLM and ALM and so on, which all need to be on the cloud. Why does it need to be on the cloud? It needs to be there because there's certain features of collaboration, like you rightly said, which are far more powerful if hosted on the cloud rather than on services on the on-prem servers and hardware, because there are features which cannot be leveraged or is not available to everybody if it is hosted on their own premises in data centers. Generative design is an example of that. PLM probably is far more efficient if it is done on the cloud. So cloud is definitely SaaS, software as a service, is definitely something that a lot of CIOs are agreeing now, and they're changing their policies within that it is better to let somebody else manage it, and they do what they do best.
But also, there's a big concern around cybersecurity, and recently we're seeing, one big example in terms of what is happening with JLR. So is that also something which is, keeping the CIOs on the fence of, jumping to the cloud direction right now?
Actually, statistics reveal that your data is more secure on a hyperscaler, on a public data center. Why? Because they spend more on encryption. They spend more on securing your data. That's their business. They cannot afford such glitches. So contrary to popular perception, it's actually far better for them to hire a public data center to store their data and compute, rather than they doing it themselves, because they might have it on the server in the next room, but that's easily hackable into. Statistics are there for it. But yeah, you're right. Because of that perception, they are on the fence. They are not quite sure whether they should jump onto the cloud very soon. I think CIOs and CDOs are leading the movement towards, if I can call it that, to move towards the cloud. But the rest of the departments probably need to be convinced by them, which is happening gradually.
And for your business in India, so you mentioned about SaaS. So is the shift happening in a very rapid fashion right now towards?
It's not happening as rapidly as we would have liked it to happen. It is happening. There are increasingly more customers that are adopting the cloud, but not at the pace that we had expected or the whole market had expected it to switch. But it is happening to an extent. Also because a lot of data centers are still not, many of these services are not provisioned in the country, and their data residency issues of having it in a different country, and it has to be connected to that, etc. So there's a little bit of that barrier which the hyperscalers need to solve, and it's happening. They've recognized it. I think Microsoft's got good data center provisions here, but others need to catch up as well. It's a matter of changing policy within organizations to realize the benefit of two things. One is the costs of administration that the companies are incurring if they put it on their own data center, and the other is the additional features which a SaaS solution inherently brings.
So you're optimistic about it?
We are, and we have been for a long time. So I think in all technology adoptions, it's a hockey stick curve. People believe it's coming.
Some
It's
friction
coming.
initially.
There's a lot of friction initially, and then suddenly it kicks in. I hope we are at that inflection point where it's going up from here.
Right. You mentioned about ALMs and how they're also seeing a good offtake in the market right now. India is considered to be the global software powerhouse. So what potential do you see in the country when we talk about software defined vehicles, and what potential do you see for your ALM tools in the market?
Yeah, ALM, it's called Codebeamer. It's actually doing pretty well in the market. I mean, all major OEMs across the world are using it, particularly European OEMs. Indian OEMs are getting on that curve as well. There's plenty of adoption happening here. India is very well positioned, given that we have been the software engineering hub for 3 decades, probably more, and given that embedded systems and semiconductors is a big push by the government. Given that our automotive industry is growing pretty fast right now, if you see the statistics, you see how much more people are spending on automotives now for a premium automotive. For all these factors, I think India is in an excellent position to ride this wave. I think software engineers are there. We've got millions of software coders right now. There's a lot of European OEMs which have built a GCC in India in collaboration with some of our software hubs to offshore some of the software development vehicle in the SDV space. We've got a lot of people who are picking up the automotive nuances to ensure that the vehicle software. Now, vehicle software is, you need to understand not just coding, but you also need to understand the dynamics of what the vehicle requires, what the features are that is required within the vehicle. People are picking that up. And there are, I think the biggest example is of BMW and Tata Technologies doing a lot of work. There's plenty of offshoring happening, and they've built a joint venture, which and they're hiring big to ensure that vehicle software is developed here. There's plenty of work happening. India is in a very good position. I think we need to make sure that we are very process oriented. We do fundamentally good work with good tools as well.
Right. So that brings me to this point of collaboration. So although you spoke initially on that, but do you see this stakeholder collaboration sort of increasing going forward between OEMs, ancillaries, and technology companies who are really into software, data, AI?
Yeah, plenty. I think traditionally there was a lot of embedded software or firmware coming from the tier ones. They would give their component with software embedded in it, and the OEMs would adopt it and use it, right? And the small changes, and those were the electromechanical components. Now with software being the heart of the vehicle, and OEMs realizing that when it's the heart of the vehicle, they need to own the software completely. They can't depend on the tier ones or the ancillary component manufacturers, like you said. So they have now started taking it in-house. We know all the big names in India doing that, building large software teams, etc. So that's a drive which is happening in the market, has been there for 3, 4, 5 years. And they are ensuring that collaboration is happening within the various teams with digital. And also that the electromechanical engineering teams, or we call it the traditional core engineering teams, are collaborating very well with the software engineering teams, because now it's going to be software led. That's essentially what software defined vehicle is about. It's not about using software inside an enterprise, which has been happening for a while now. It's about thinking software first rather than hardware first, which has been the traditional model of doing it. You had distributed ECUs, 70 to 100 of them within a vehicle, and they all did their function. Engines, brakes, steering, airbags, and so on. But now you are going to have very powerful electronic control units driven by software, bundled or tied into a central software architecture. And that determines how the car should be designed and engineered. So that's the true essence of software-defined vehicle. which a lot of companies are doing already. So that's a coming together of the traditional PLM software and what we are calling the ALM software. And it's going to be an integrated engineering effort within companies as we move forward. And companies are embracing it. I mean, I know a lot of, even last week I was talking to someone senior in a commercial vehicle manufacturer, and he was telling me that, in future we're going to have integrated PLM and ALM, so we need to take care of that. And I think that's resonating with the market, and people realize that the product will be now not just hardware but also software. In fact, it'll be software driven, software in the front.
Right. Just lastly, Rajkiran, where do you see going forward, maybe 5 years down the line? How would you differentiate between a successful SDV program vis-a-vis, something which is not that successful in the market?
Adopting fundamental practices, adopting fundamentally sound practices, putting the right systems in place, putting the right foundation in place. And now it's easier said than done, because a lot of companies have been doing it a certain way over many years.
Right.
But they need to do things. They need to move away from documents to models, for example, 3D models.
Yeah.
They should adopt a model-based enterprise. They should think model-based. Like I said earlier, the car is actually born in concept phase, and it has impact from the concept or design stage through its entire life cycle.
Sure.
So how do you ensure that a model which is developed in the concept phase or in the design phase is understood very clearly by different departments and different stages throughout its life cycle, right up to aftermarket and retirement? So that model should be the single source of truth, and that should be enriched with more and more data as it moves through its life cycle. That's where the concept of digital twin comes in. That's where the concept of PLM, of course, comes in. But how do you fundamentally adopt the tools that are required for everyone to understand what's happening in different departments? For that, it requires visionary change within automotives. They need to look at high quality, best of breed softwares for doing model-based definition, model-based systems engineering, which is to make sure that complex systems which have electrical, mechanical, software components are defined as one, and then you define the features encompassing all of these three disciplines, and then design fundamentally correctly. So with software coming in, there's a lot of this. There needs to be extra focus on doing it better. So that's the one thing that I think a lot of CTOs, CDOs are recognizing, that we would like to see better in the market. It is going in the right direction. So they need to put in good systems in place, good softwares in place.
Right. On that note, Rajkiran, very articulate. Thank you so much for chatting with me.
You're welcome. It was a pleasure. Thanks, Mayank.
Thank you.